Here we go. We have, again, a Gaussian splat in front of us. This is the same centricity convention center in Cape Town. The Gaussian splat that we have in front of us has also been exported and given to us as an OBJ file. The OBJ file is not necessarily immediately importable into SketchUp. However, there is a wonderful tool called Universal Importer. When you see it downloaded from the SketchUcation website, you'll see that it is possible to reduce the polygon count in the model. Please take note that that explicitly happens for everything that appears in the model. So rather than doing that, always go to File, Import with the Universal Importer, and then select your file. In this case, the OBJ file. When that imports, it will ask to reduce the polygon count. I always advise people, please reduce your polygon count to be below 1 million or preferably around 400,000 for a single object. Then, as with so many other things imported into SketchUp in a non-native SketchUp format, the amount of triangulation that we then experience in an asset like this means that we can right-click and say Soften Smooth Edges, under which the Soften and Smooth Edges window opens, and then we can simply select Soften Coplanar. That way the object will appear slightly smoother. And we can switch between the different SketchUp styles to continue to use a style that is a fast style, so that a computer is not using too much of our memory banks to focus on rendering the actual object. One can see that as part of this object, a lot of the geometry that was created in the Gaussian splat as the peripheral scanning data, as in through the window into the rest of the world, is still visible here in the model, which would have been cropped out before the OBJ export took place. For now, this is enough of what we want to work with. I'm going to give you a small demonstration. If I draw a rectangle as part of the floor plan here, and I move that object around, say vertically, and I right click and say intersect the faces with the model. What I would want to see is that it would intersect with the Gaussian splat on the points where it hits the various pillars. Now, unfortunately, and maybe this is new for you, maybe this is information that you've already learned, this doesn't work. There's no connection between the splat and the line work of the rectangle. In part, that is because this is simply a reference model. This is not the actual model itself. This is not a mesh. In another way of looking at this, currently in our viewport display, we see that this is considered the rendering mode. We can switch to the model mode, and we can switch to the point cloud mode. The point cloud mode allows us, especially when we leave snapping to point cloud or snapping to Gaussian splat on, we can quickly snap to the corner of this column and quickly snap to the other column on the other side. And we are then hence left with a viable interior dimension column to column, excuse me. Keeping that in mind, if we then turn our snapping onto SketchUp, we can then snap from this corner to the next corner, and we can estimate that this is about 7.8 meters. Now, that's not necessarily a bad way to model. We could draw a rectangle. We could say, okay, this is the ground floor plane right up to reception. We can simply make that a group or a component. We can then extrapolate by snapping to the scan data that this is the size of the column, 700 by 960 millimeters. And then we can extrapolate that into a 3D shape. And as long as we make that a component, and we then duplicate that component throughout the space, hopefully we have a component that is easy to reuse or replicate at a distance of 8.4, 8.5 millimeters. Then these three columns combined, spaced vertically at a distance of 7.4 millimeters, or 7,400 millimeters, 7.4 meters. This will then give us When we remove the Gaussian splat, a rough overview of what this would look like as a 3D model or as perhaps a floor plan. So we can simply switch to an elevation view and a parallel projection to make sure that this all appears as intended. And then this is our distance between the columns. We said that was around 7.9 meters. Yeah, 7,750. And this space is 6,348. Start point to end point is 8.47. And here it's 8,500. Okay, so that's a relatively simple distance and grid that we can set out based off our Gaussian splat. Now this is one way of doing this. Let's go to the other way. We now have similar splat. And what we'll do is we'll draw again the same rectangle. I'll make it a group as well. We will now, in the OBJ environment, move this rectangular face upward by about, let's call it 2 meters. Let's see if it can process that data. Yes, there it is. And then what we will do is we will select the face of that rectangle, right click and say intersect the faces with the model. It will then need some time to calculate that. But as soon as we hide the mesh, we can see a rough floor plan, and then this is obviously what we're left with. Now, unfortunately, the OBJ export or the conversion to a DAE file does not instantaneously give us straight lines. But it's probably the closest approximation that we have in the SketchUp concept, the SketchUp context, to create a model out of a splat or a scan. The other method, where we drew the space directly on top of an existing Gaussian splat, is a little bit more straightforward because what we present ourselves with is a sort of see-through version of the model, of the environment, and so we can much easier draw our columns, our walls, and our flooring. Having said that, we can then switch still between the point cloud mode and the rendering mode, so we're also very aware to the visual style of each of these objects. Having seen the differences between these two models, can I ask you to leave in the comments any suggestions that you have or any observations that you have around why this is useful or what this could be used for in the long term? I think in SketchUp we are not too far from being able to process imagery or PDFs into DXF to create a proper floor plan. And with software out there like Magic Plan, where you can visit a site with an iPad and make notes or measure using an AR tool the distances from wall to wall, we can simply draw out floor plans that way in CAD on site without having to go back into SketchUp to edit these. For a function or for a hole this size, a plan from Magic Plan might still be too cumbersome. It might be too complex. But I do believe that with their 90-degree angled software, you can really easily map out commercial buildings where you would expect a lot of rectangular rooms to be present with columns and a variety of staircases. So for now, I'm going to sign off and ask you to put in the comment what your favorite way of working is, your favorite method. Please bear in mind the OBJ that I received did not have a texture file associated with it. But that is not to say that it is not possible to import an OBJ that is colorized. For now, thank you for your time, and I wish you a great week.